Hey there, fellow space explorers. Welcome to another deep dive. Today, we're going to be looking at the mind-blowing discoveries from the James Webb Space Telescope. Just 3 years in, and it's already shaking up everything we thought we knew. And for any UPSC aspirants listening in, this deep dive is a gold mine for your science and technology prep.
It really is an incredible time for astronomy. The JWST is like having a time machine, peering back billions of years to reveal the universe's earliest secrets.
Okay, let's unpack this. One of the biggest surprises has been the discovery of these incredibly massive galaxies that existed when the universe was just a baby, a mere 300 million years old. We're talking galaxies with masses hundreds of millions of times greater than our sun. It's making scientists rethink how quickly galaxies can form and evolve.
What's fascinating is that this challenges the traditional model of galaxy formation. We used to think it took billions of years for galaxies to reach such sizes. Now, the James Webb Telescope is showing us that massive galaxies were already in existence when the universe was just getting started.
It's almost like finding a skyscraper in a newly founded town. It just doesn't fit our expectations. And here's where things get even weirder. These early galaxies are unexpectedly blue. Now, space is full of colorful objects, but this blue hue is a real head-scratcher.
That's because as galaxies age, the dust from dying stars makes them appear redder. Think of it like a sunset, where the dust in the atmosphere scatters the blue light and makes the sky appear red. But these early galaxies, as massive as they are practically dust-free, hence the surprising blue color.
So is this a sign that early stars formed and died differently than we thought? Like, maybe they didn't explode as violently, creating less dust.
That's one of the leading theories. It could be that early stars were much larger and lived shorter lives, collapsing directly into black holes without the dramatic supernova explosions we see today. Another idea is that powerful supernovae might have blasted the dust far away from the galaxies, leaving the core surprisingly blue.
It's like a cosmic mystery with several possible solutions. And to make things even more intriguing, the James Webb Telescope is also revealing strange chemical compositions in these early galaxies.
We're seeing higher than expected levels of nitrogen, which is a key ingredient for life as we know it. But at the same time, these galaxies have surprisingly low amounts of other heavy elements or metals. This unexpected chemical makeup is throwing a wrench in our understanding of how stars contribute to a galaxy's evolution.
So while we're getting closer to understanding the conditions that might lead to life, we're also realizing that the early universe was a much more complex and dynamic place than we initially imagined.
Absolutely. And speaking of seeing further, the James Webb Telescope has another trick up its sleeve. It can use massive galaxy clusters as a sort of cosmic magnifying glass.
Wait, hold on. Galaxies acting as magnifying glasses? How does that even work?
It's a phenomenon called gravitational lensing. Imagine you're looking at a distant object and someone holds a magnifying glass in front of it. The light from the object bends around the glass, making it appear larger. The same thing happens in space, but instead of a glass lens, we have the immense gravity of a galaxy cluster, bending and magnifying the light from even more distant galaxies behind it.
So it's like having a built-in zoom lens for the universe. What kind of incredible details is the James Webb Telescope picking up with this cosmic zoom?
Well, it's finding far more faint galaxies than we ever anticipated. These are galaxies so dim that they would be practically invisible without the help of gravitational lensing. And the sheer number of these faint galaxies is telling us that the early universe was even more active than we thought, brimming with star formation.
This is starting to sound like a whole new chapter in the story of the universe. It's like we're getting a glimpse behind the scenes of the cosmic drama that unfolded billions of years ago. And those faint galaxies, they're not just faint, they're also incredibly energetic.
Exactly. And this energy, this light they're emitting, it's painting a whole new picture of the period shortly after the Big Bang, a period known as the cosmic dark ages. Before stars and galaxies ignited, the universe was filled with a neutral hydrogen gas that absorbed most of the light. It was a dark, quiet time.
So are you saying these faint, energetic galaxies played a role in ending the cosmic dark ages and bringing light to the universe?
That's the current thinking. These small, energetic galaxies might have been the key players in reionizing the universe, splitting those neutral hydrogen atoms and allowing light to travel freely. It's like they were the cosmic lanterns that lit up the universe, paving the way for the galaxies we see today. And speaking of strange and unexpected galaxies, the James Webb Telescope has also stumbled upon a group of mysterious objects that have astronomers scratching their heads. They call them little red dots.
Okay, you can't just drop a bombshell like that and not elaborate. What are these little red dots, and why are they causing such a stir in the astronomy world? What makes them so different from the blue galaxies we've been talking about?
Well, imagine you're looking at an image of the early universe taken by the James Webb Telescope. You see these compact, intensely red sources of light scattered amongst the more familiar galaxies. At first glance, scientists thought they might be just super dense galaxies packed with red stars. But further observations have revealed something much stranger.
All right, I'm hooked. Tell me more. What's so strange about these red dots? Are they like the opposite of the blue galaxies?
In a way, yes. They seem to defy easy categorization. On the one hand, they show signs of having supermassive black holes at their centers, actively devouring gas and dust. These are called active galactic nuclei, or AGN. But here's the catch. They're not emitting the strong X-rays that we typically expect from AGNs. It's like finding a roaring fire that doesn't give off any heat.
So are we talking about black holes on a cosmic diet, maybe? Perhaps they've already gobbled up most of the surrounding gas and dust, and that's why they're not as bright in X-rays.
That's one possibility. But here's where things get even more perplexing. These little red dots, besides their black hole activity, also display features that suggest they have significant star populations.
Well, hold on. So they have characteristics of both black holes and star-filled galaxies. Are we talking about some kind of cosmic hybrid, a new type of object we've never seen before?
That's precisely what astronomers are trying to figure out. Some believe these little red dots could represent a transitional phase in galaxy evolution, a phase where both black holes and stars are forming and influencing each other in ways we don't fully understand. It's like catching a rare glimpse into a critical moment in the life cycle of a galaxy.
This is blowing my mind. We've gone from super efficient blue galaxies to cosmic magnifying glasses to these mysterious red dots. It's like the James Webb Telescope is a cosmic detective, unearthing clues about the universe's most formative years, revealing that the early universe was much more diverse than we initially thought. But hey, who are we to complain? This is exactly the kind of deep dive we live for.
It's truly remarkable. And believe it or not, we've only just begun to explore the vast amount of data the James Webb Telescope is sending back. There are so many more mysteries waiting to be uncovered, so many more secrets hidden within the depths of space. And for anyone preparing for the UPSC exams, understanding these discoveries is like having a cheat sheet for the universe.
Don't forget, folks, we're just getting started. There's much more to explore in this deep dive, so make sure to hit that subscribe button and stay tuned for the next part, where we'll delve even deeper into the wonders revealed by the James Webb Space Telescope. And don't forget to share this deep dive with your fellow space enthusiasts and UPSC aspirants.
Welcome back, space enthusiasts. We've been exploring the surprising activity in the early universe. But it turns out, the James Webb Telescope is also finding evidence of the opposite. Galaxies that form stars at a furious pace, and then, for some reason, just, stopped.
You're talking about those galaxy corpses we teased earlier, right? I'm still wrapping my head around the idea of a galaxy just shutting down like that. Sounds almost eerie.
It is a bit like stumbling upon a ghost town in space. These galaxies are massive, comparable in size to our own Milky Way, and they show clear signs of past star formation. But all of that activity has ceased. They're like cosmic time capsules, frozen in a state of quiescence.
So how does the James Webb Telescope even detect these dead galaxies? They're not exactly bursting with light and energy like those blue behemoths we talked about.
They still emit light, just not the kind associated with newborn stars. It's more like the faint glow of an aging population. And the amazing thing is that JWST can analyze this light in incredible detail. It's like looking at the spectral fingerprints of a galaxy, revealing its chemical composition, its age, and even clues about what might have caused its star formation to grind to a halt.
And what are those clues telling us? What could possibly cause a galaxy to just stop forming stars? It seems like such a fundamental process.
That's the million-dollar question. And it's one that has astronomers buzzing. One possibility is that these galaxies simply ran out of fuel. Star formation requires vast amounts of cold gas, and perhaps these early galaxies consumed all of their gas reserves in a burst of stellar creation, leaving them with nothing left to fuel future generations of stars.
So it's like a cosmic feast followed by a famine. But couldn't these galaxies pull in more gas from their surroundings? Isn't space filled with vast clouds of gas and dust?
You'd think so, wouldn't you? But another theory suggests that something might be actively preventing these galaxies from accreting new gas. Perhaps powerful feedback from supermassive black holes at their centers is heating up the surrounding gas, making it too hot and energetic to collapse and form new stars.
So it's like a cosmic tug of war. with the black hole acting as a kind of galactic thermostat, controlling the rate of star formation. But if these galaxies shut down so early in the universe's history, doesn't that mean they must have formed incredibly quickly?
Exactly, and that's the real head-scratcher. The James Webb Telescope is finding galaxy corpses that formed and went quiet within the first 700 million years after the Big Bang. That's a blink of an eye in cosmic terms. It challenges our current models of galaxy formation, which suggests that galaxies grow and evolve much more gradually.
So are we talking about rewriting the textbooks on galaxy evolution? Is the James Webb Telescope forcing us to rethink everything we thought we knew about how galaxies are born, live, and die?
It's certainly prompting a major reassessment. Some cosmologists believe our existing models can be adjusted to accommodate these new observations, perhaps by tweaking the parameters of early star formation efficiency. But others are suggesting we might need to go back to the drawing board and consider more radical explanation.
Like what kind of radical explanations? What other factors could be at play that we haven't even considered?
Well, one of the big mysteries in cosmology is the role of dark matter. We know it's out there, making up the vast majority of the universe's mass. And we know it exerts a gravitational pull on galaxies. But we still don't fully understand how dark matter interacts with ordinary matter, or how it influences the formation and evolution of galaxies.
So are you saying that these early, massive, and dead galaxies could hold clues to the nature of dark matter itself? It's like we're trying to solve a cosmic jigsaw puzzle, and the James Webb Telescope is giving us these tantalizing pieces that don't quite fit the picture we had in mind.
Precisely. And the more we learn about these early galaxies, the more we realize how much we still don't know. It's a humbling experience, but it's also incredibly exciting. We're on the verge of a major paradigm shift in our understanding of the universe, and the James Webb Telescope is leading the charge.
And to think, we've only just begun to analyze the data it's sending back. Who knows what other surprises await us in the years to come? It seems like with every observation, the James Webb Telescope is raising more questions than it answers.
That's the beauty of scientific exploration, isn't it? Every discovery opens up new avenues of inquiry, pushing us to delve deeper, to question our assumptions, and to expand our understanding of the cosmos.
Speaking of questions and mysteries, remember those enigmatic little red dots we discussed earlier? The ones that seem to have characteristics of both black holes and star-forming galaxies.
Yes, those little red dots are a fascinating puzzle, and they tie in directly to some of the biggest questions in astronomy.
Okay, rewind for a second. I remember you saying they might represent a transitional phase in galaxy evolution, but how does that connect to the bigger picture of how galaxies form and evolve?
Well, one of the long-standing mysteries in astronomy is how supermassive black holes, millions or even billions of times the mass of our sun, form in the first place. We know they exist at the centers of most galaxies, including our own Milky Way, but their origin story is still shrouded in mystery.
I remember learning about that in school. It's mind-boggling to think about something so massive and dense lurking at the heart of a galaxy.
And then there's the question of how stars and black holes influence each other's formation within galaxies. Do they form independently? Or is there some sort of cosmic dance between them, a feedback loop where they shape each other's destiny?
So how do those little red dots fit into all of this? Are they giving us clues about this cosmic dance between stars and black holes?
That's precisely what makes them so intriguing. If they truly are a combination of both star formation and an active black hole, they could be a snapshot of a very specific stage in galaxy evolution, a stage where both processes are intertwined, perhaps even interdependent.
It's like catching a glimpse of a rare cosmic event, a fleeting moment in time that could hold the key to unlocking bigger mysteries about the formation and evolution of galaxies, and perhaps even the universe itself. But how can we be sure that these little red dots are really what we think they are?
Well, that's where the power of the James Webb Telescope truly shines. It's not just about capturing stunning images. It's about analyzing the light from these objects in exquisite detail, breaking it down into its constituent colors, or wavelength. This spectral analysis allows astronomers to identify the chemical elements present in these objects, to measure their temperatures, and to infer the physical processes taking place within them.
So it's like using light as a cosmic Rosetta Stone, decoding the messages hidden within the glow of distant galaxies. And what are those messages telling us about the little red dots?
The spectral data from these objects is still being analyzed, but initial findings are both exciting and puzzling. They confirm the presence of supermassive black holes actively accreting matter, as evidenced by the broad emission lines characteristic of AGNs, but they also reveal strong signatures of star formation. suggesting that these objects are not simply dormant black holes, but rather complex systems where stars and black holes are coexisting and perhaps even interacting.
It's like watching a cosmic ballet, where stars and black holes are swirling around each other, each influencing the other's movements.
That's a beautiful way to put it. And the James Webb Telescope is giving us front row seats to this cosmic performance. It's a privilege to be alive at a time when we can witness such profound discoveries. To peer back billions of years and glimpse the universe in its infancy.
It really is a remarkable time for astronomy. And the best part is, this is just the beginning. The James Webb Telescope has a long mission ahead of it. And with each new observation, it's bound to uncover more surprises, more mysteries, and more insights into the grand cosmic story. Stay tuned for the final part of our deep dive as we explore even more groundbreaking discoveries from the James Webb Space Telescope. Don't forget to hit subscribe and share this deep dive with your fellow space enthusiasts. Welcome back to the final part of our deep dive into the James Webb Space Telescope's most incredible discoveries. We've journeyed to the early universe, witnessed the birth and death of galaxies, and even encountered those mysterious little red dots that have left astronomers both excited and puzzled. And for all of our UPSC aspirants out there, remember this is all crucial material for your science and technology prep. The James Webb Telescope is rewriting the textbooks on the universe.
It's truly a golden age for anyone fascinated by the cosmos. We're seeing things no human has ever seen before, pushing the boundaries of our knowledge and challenging long-held theories.
Okay, let's recap some of the key takeaways. We talked about those massive blue galaxies that existed when the universe was incredibly young. This means the universe was creating giant galaxies much earlier than we thought, shaking up our understanding of how galaxies evolve.
And then there are those galaxy corpses, those massive galaxies that formed stars rapidly and then went quiet. They're like cosmic time capsules, frozen in a state that defies our expectations.
But not as like they lived fast and died young, on a cosmic timescale, of course.
Yeah.
And their existence is pushing us to rethink the role of dark matter in galaxy formation.
Right. It's a reminder that we're still piecing together the puzzle of the universe. And the James Webb Telescope is giving us these tantalizing pieces that don't always fit neatly into the picture we had in mind. And then, of course, we can't forget about those little red dots.
Those enigmatic objects that seem to have characteristics of both black holes and star-forming galaxies. They're like the platypus of the cosmos, defying easy categorization.
Exactly. And the more we learn about them, the more intriguing they become. They could be a missing link in our understanding of how supermassive black holes form and how they influence the evolution of their host galaxies.
It's like they're revealing a hidden chapter in the story of the universe. A chapter where stars and black holes are engaged in a cosmic dance, shaping each other's destinies. And all of this is just from the first few years of the James Webb Telescope's mission.
Imagine what we'll discover in the decades to come. It's a truly exciting time to be an astronomer, and the James Webb Telescope is at the forefront of this revolution in our understanding of the universe.
It's like having a front row seat to the greatest show in the universe, a show that's been unfolding for billions of years. And the James Webb Telescope is allowing us to not only watch, but to begin to understand the intricate choreography of this cosmic ballet.
And for those of you preparing for the UPSC exams, remember this. Understanding the latest discoveries from the James Webb Telescope is not just about science and technology. It's about grasping the grand narrative of the universe, a narrative that is still being written.
It's a story that's full of surprises, mysteries, and awe-inspiring beauty. And we're incredibly fortunate to be living in a time when we can witness these discoveries firsthand.
So keep looking up, keep asking questions, and never lose your sense of wonder. The universe is full of secrets waiting to be uncovered. And who knows what other wonders we'll find in the years to come.
That's right. And on that note, we've reached the end of our deep dive into the James Webb Space Telescope's most incredible discoveries. We hope you've enjoyed the journey as much as we have, if you did. Don't forget to like, subscribe, and share this deep dive with your fellow space enthusiasts and UPSC aspirants. Until next time, keep exploring the cosmos. And never stop questioning the universe around you.